Hello, today we're going to be graphing square root functions. So we're going to start by looking at a quadratic function and remembering how these quadratic functions get moved all around. So to find the vertex, we took whatever was inside with the x and we do the opposite. So the +1 becomes -1. And then we took whatever your k value was and we just left it alone. So your vertex is -1, -4. Your stretch of 2 was applied to that 1, 3, and 5 pattern. You're going to take and you're going to multiply those by 2. So it's going to become 2, 6, and 10, which means we're going to go over 1 and up 2 on each side, then over 1 and up 6 on each side, and then over 1 and up 10, and we're off the graph grid. So our graph of a quadratic function, anything that has a squared, is going to look like that U shape based off of that pattern. Now our domain for this from left to right is going to be -infinity to +infinity because our arrows go left and right on the graph. Your range goes from low to high. So if you're looking at your range here, my graph starts here at -4, and it goes up to +infinity. So my range is -4 to +infinity. Now the transformation is how this graph is moved. So this +1 here moved my graph left 1. This -4 here moved my graph down 4. And this 2 out in front moved my graph by a vertical stretch of 2. So we're going to be using similar ideas here, but we're going to be doing something called a square root function. The square root functions, the graph is going to look like this, and we're going to explore how to move everything all around. So what you're going to do is you're going to go to student.desmos.com, you're going to type in this code, and when you do that, you're going to end up getting something that looks like this once you type in that code. Now, when you hit go, you're going to have an activity where you're going to start moving these square root functions around. So you're going to have an equation, and on here it says move the graph right 1. So you're going to be typing in like y equals, and so you can just type in the equation, try plugging in a number, and seeing what actually makes the graph move right 1. Now, I want you to do this, and then while you're doing this, pause the video. Once you are done, come back and see if your answers here match up with mine. So you take a little bit of time, pause the video, type in a bunch of stuff, and see if then when you come back here, your answers match up. Okay, so here were the equations. The first one that moved right 1 had a -1 inside of the square root. If you had a left 3, you had a +3 inside the square root. To go up 2, you had +2 at the end. To go down 5, you have -5 at the end. And to flip over the x-axis, you had that negative sign out in front. Now these should seem somewhat familiar because while the shape of the graph is different, how we're moving that graph all around is the same. So let's take a look at what makes the shape of this graph. So we're going to take a look at y equals the square root of x. Now if you think about what numbers you were going to use for our table here, you want to think about what numbers are nice to square root. So for instance, think of some numbers that you know the square root of. Like you know the square root of 4, you know the square root of 9, you know the square root of 16 and 25. You also know the square root of 1, and you also know the square root of 0. Those ones you might need to think about for a little bit, but we can take the square root of 0. In fact, when we do, the square root of 0 is 0. The square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. So if we were to graph this table of values, those are going to give us the graph of the square root of x. So we're going to use 0, 0, 1, 1, 4, 2, 9, 3, and then we're off the graph grid. Now, to connect this graph, we want to make sure that we're connecting it and making the graph accurate. If you think about negative numbers, if I would have asked you the square root of -1, we would not have been able to do that. So our graph here does not go into the negatives, meaning it's going to start at 0, 0. And that makes our domain from left to right 0 to positive infinity. And it makes our range from low to high 0 to positive infinity as well. So it's a little bit different than the graph of your quadratic because it's not negative to infinity for anything. For your domain and range, it starts off as 0 to infinity for both of those. Now my x-intercept starting off is 0, 0, as is my y-intercept because that's where my graph hits both the x-axis and the y-axis. So you can imagine that when we start moving this graph around, your x-intercept and your y-intercept might change as well. So this is the generic function. Now we're going to move it left and up and flip it over and stretch it and all of that different stuff. So the things that we need to know here. So the first thing is you're going to have the square root. Your a value out in front is just like your a value when you did quadratics. So this is going to be a vertical stretch if your a value is greater than 1. So for instance, if your a value is 2, it's a vertical stretch. It's going to be a vertical compression, or you might use the word shrink, and that's totally fine. If your a value is a fraction. So for instance, if a is 1/2 or 2/3, it's going to be a vertical compression. But your a value does one more thing. It also is going to reflect or flip over your x-axis. And that happens when a is negative. The h part is going to do exactly the same thing that it did with your quadratics, meaning it's going to move the graph left and right. Now, just like with quadratics as well, it's going to do the opposite of what you think it should. So it's going to be left if it's x plus some number, and it's going to be right if it's x minus some number. But notice those have to be under the square roots in order to move left and right. It's kind of like in order to move left and right for quadratics, it had to be in parentheses being squared. So in order to move left and right, it has to be under the square root. The k value at the end is going to move your graph up or down, just like it did with your quadratics. To move up, if you have square root of x, and then outside of the square root, you have plus some number that goes up. Down would be the square root of x minus some number. It would go down. Your domain and your range, they're going to depend on the graph. So if you are good at reading it from the graph, you can just look at your graph and read your domain and your range. Otherwise, your domain is always going to start at how far left and right your graph went, and then it's always going to go to the right for forever. And your range will either start at how far up and down you went and went up for forever, or it's going to start pointing down and get up to however you shifted up and down. So really it depends on your graph. I would look at your graph for your domain and your range, but if you like using H and K, you can look at these as well. The other thing that we're going to need to know that's going to be slightly different than quadratics is you're going to need to know your table of values. So you're going to need to know 0, 1, 4, and 9. These numbers are nice to square root. So think about what your perfect squares are. Those are going to be the x values that you have to have memorized. Your y values, what you're going to do is you're going to plug x in order to find your y value. So for these ones, the square root of 0 is 0, 1, 2, and 3, but we're going to find those by plugging x into our equation. So let's take a look at our first example where we're going to graph this by hand. So looking at this, we have this minus 3 inside. This is going to move our graph right by 3. We have the plus 2 outside. That's going to move our graph up 2. So what we're going to do is, looking at your table values off on the side here, we're going to write those numbers that I said we need to memorize. The 0, 1, 4, and 9. The numbers that are nice to square root. And then what we're going to do is, upon our x values, we're going to be adding h to it. So we're going to start taking and we're going to move them left and right based off of however we said. So for these ones we said we'll move right 3, which means for these we're going to be adding 3. So we're going to do 0 plus 3 to get 3, 1 plus 3 to get 4, 4 plus 3 to get 7, 9 plus 3 to get 12. To get your y values, what we're going to do is we're going to plug x in and we're going to see what we get back out. So we're going to plug it into our original equation here. So for this one, we're going to take the square root of the value we're plugging in here is 3. And you may use your calculator. You can do this by yourself, however you want to do this. If you're using your calculator, you're going to have to close your parentheses. So we're going to do 3 minus 3. So we are taking the square root of 0 and adding 2 to it. So we're going to go ahead and say that that's going to end up equaling 2. For our next one, we're going to plug in our x value of 4 into our equation. So we are taking the square root of 4 minus 3, which is 1, and adding 2 to that. So the square root of 1, which is 1, plus 2 would give us a 3 back out. For our next one, we're going to do the square root. The number we're plugging in is 7. So we are taking the square root. Oh, I wrote a 4 there. So it's 7 minus 3. We're taking the square root of 4 and adding 2 to that. 2 plus 2 would give us 4. Our next number we're plugging in is 12. We're plugging it in for our x value. So we get the square root of 9 plus 2. So 3 plus 2 would give us 5 back out. So we're going to graph each of those points, 3, 2, 4, 3, 7, 4, and 12, 5. And we're going to connect those starting at whatever this top value is. That's your starting value, 3, 2. You don't go past that. So if you think of your normal square root graph, we said we were supposed to move right 3 and up 2, and we can see that this graph supports that. So now our domain from left to right is going to start here at 3 and go to the right for forever. So our domain is going to be 3, infinity. And our range is going to start here at 2 and go up for forever. So it's going to be 2, infinity for that one. So that's how we graph our square root functions. We're going to practice a couple more because it just takes a little bit of getting used to. So taking a look at this here, we have this minus 5 out or inside that's going to go right 5. The 1/4 out in front is a vertical compression of 1/4. And the plus 3 at the end is going to move your graph up 3. So we're going to take 0, 1, 4, and 9. Those are the ones you have to memorize for your x values. And we're going to add h to them, which in this case means we're going to add 5 to them. So here's where I'm going to pause for this video. I'm going to break this up so that I don't have to rush it. So please tune back in to finish up example 2 together and then example 3 as well. Thank you.